Yeah. Oh, shoot. Well, that's what I'm on. Like, if it. There's like a hole. Okay. So this is sample multiple choice over 12, and I hear a couple of things going on. You need to be careful that this question doesn't ask you about volume at all. It only asks you about area. Okay. So you have no calculator. The first thing you're going to have to do is find those points of intersection. Okay. First one's easy. That first one is 0, 0. We're going to find the other one. So that means putting work on your paper. You have no calculator. So how do you find a point of intersection? So 5x minus x squared equals 2x. Has anybody already finished that? 3. X equals 0 and x equals 3.
Y equals 6.
All right. That, sometimes that solves us out. We have trouble solving, but most of the time they're not trying to make it too tricky when you're trying to just get points of intersection. So there it is. And then you just find the area. And to find the area, you add up, yes, a bunch of rectangles. And how tall are the rectangles? They're this tall, which is the parabola minus the line. Whatever way you've numbered them, okay? So the parabola is 5x minus x squared minus 2x dx. Now, we have to evaluate it from 0 to 3. And when I asked you to do this, I hadn't shown you how to take this definite interval without your calculator. So now we are going to take this without our calculator, okay? When you have to do a derivative or a definite interval without your calculator, please try to clean it up before you start. It'll just save you some time. So can you add anything together?
Yes.
3x minus x squared dx. We just learned this yesterday, day before yesterday. And we got this, right? It's backwards taking the derivative. So you add one antiderivative, x squared, and 3 over 2, the 3 that's there already, and put the 1/2, remember antiderivatives? Okay, minus 1/3 cubed. And then the only new thing is the bracket. Very good. 0 to 3. And what does that tell you to do? Plug in the 0 and subtract them. Okay, this is what we just learned. That's something you all are doing kind of, what are you doing? We just did this on Thursday. So this is 3 halves times 3 squared minus 1/3 times 3 cubed, and this thing over here ends up being 0. Okay, so you plug in 0, you get a bunch of zeros. So a little bit of fraction arithmetic, not much, but a little bit. Is that number 2? Minus 9, which is 9 over 2, which is choice left number 18. Right here, 3 cubed is 27. Okay. All right. So there it is. Pretty sure there's going to be a simple area question on your multiple choice part of the program somewhere. Okay, a simple area question. Okay. Good. Okay, put that one up. Pull out the 1998 actual exam. The actual 1998. I was just working on that a few minutes ago. Yeah.
Could you make your boxes the other way, like horizontally, and just proceed with the problem?
Okay. If you wanted to make your boxes this way, like this, from comes dy. Right. So your interval would be from 0 to 6, dy. And then you have to rewrite both of those equations so that they said x equals. Okay. Are you going to have to do that somewhere on this exam? Yes. So do you want to do it if you don't have to? No. Okay. I know. Okay. All right. So we're doing the 1998 one now. 25. Okay, we are in the no calculator part of the program again. Calculator part. Multiple choice number 25. Unlike the one that we just did, they don't give you a picture on this one. Right? And you don't have your calculator. Everybody found it?
Yes.
The 1998 one at one time had a piece of paper on the front of the big part. Everybody found it? That's number 25. And they did not give you the picture, but look at the two equations they gave you. You should be able to graph those, right? But you get a little quick sketch of this? On multiple choice, the work you show, nobody looks at it, but when this is a free response question, in just a few minutes, you want to watch your labeling, yes? So Y1 and Y2, get things labeled. Everyone good? Very good? If you're not careful, you'll accidentally do this piece right here. This is not what they want, right? They want the part between 0 and 2, y'all see? This is the little twist that's thrown in here. Okay, so you go over here, x equals 0 is the y-axis, x equals 2 is the vertical line at 2, right there. X equals 2. Here is the thing that we're trying to find. Yep. It's really not tricky, it's just making sure that all really brilliant math people also do. Yes? Okay, and you done with it, some of it's done. Okay, is this area again?
Yes.
Yes, not volume. Okay, so we're going to do add up a bunch of boxes from 0 to 2. So they gave you that. You didn't have to find it that time. And you need to do the top minus the bottom. So which one's the top? Another parabola. And minus the bottom. So it was a negative x, wasn't it?
Yeah.
Okay, so this will end up being and dx. All right, so once again, no calculator, we'll polynomial here. Okay, if you can get it set up, you ought to be able to compute. Let's see if we can get through that. Let's practice on. I love to put in 0 for one of the numbers of polynomials because then you lose a little bit of the arithmetic issue. They also like to put in 1 from 1 to something because 1 is a polynomial. Okay. Okay? And the answer is? Third with the choice. Are we good?
Yeah, we changed the first change the number. And once we get together, it was the same number.
Okay, all right, now I want you to flip over to the back of this one, to number 86. So this one is with the calculator. So pull the calculator out. And the added benefit of this one, now I'll let y'all read it first, and then I'll tell you the benefits. All I did is just type. Okay, read it. This area? Volume. And it's not volume of a rotation. Yes? So you get an opportunity to work one of these problems together now, yes? So that you can say, okay, I now got a really good example work. And maybe when you go back and you're trying to finish that other worksheet, you'll have a little bit better luck. So it says cross sections. I have yet to see one that doesn't say perpendicular to the x-axis. As soon as it says that, you do this. I don't care if you make it an open box or a line or what. There's what it's talking about. That means what direction is this problem, dx or dy? Dx. Okay, so this is dx. It says semicircle. And we are going to be in dx. Okay? So before you worry about drawing anything, you need to write down how to find the area of a semicircle. It gets turned into volume when you put the dx on it. It's like semicircle, dx. That turns it into volume, okay? So you're going to add up an infinite number of semicircles. What's the formula for a semicircle? 1/2 pi. I'm going to write radius. If you want to write r, that's fine. I do better when I just say radius. It just helps. You can put the 1/2 in or you put the 1/2 out. And we are dx, so this is 0 to 8. When you're on the free response, if you write this down, this is a 3-point question every time. You get 1 point. If you get this right in the structure, okay? So now we've got to figure out the radius of this semicircle. So this is the part that we did at the end of class the other day, so I'm going to do it again. This is the bottom. This is something sitting down. I can't make a triangle out of this. Okay. It's sitting down on the floor. Okay, like this. And then the shape pops up from it. Let's see if I can do it like that. Up here, it's tall. Down here, it's very short. Pops up. I'm going this way, and it gets shorter and shorter and shorter. Like a bugle that's been cut in half. Is that what somebody said the other day? Right, because that's kind of what you're looking at. You don't have to be able to visualize it though, you just have to understand that this thing right here, this, I'm going to put it right here, this is that. And popping out of the page at me is a semicircle. Popping out of the page is a square. Popping out of the page is a triangle. Whatever it says, pull it out of the picture and draw it. Okay? Now there's your semicircle. How long is this? They gave it to you, right?
Yeah.
Why? What was it?
X plus 2 I believe.
So we have to change that, right? Okay, everybody change that right now. Y equals A. We need to change that into Y. A minus X over 2. Is that good?
Yeah.
All right. So how tall is that? It's 8 minus whatever X is over 2. So how wide is that? It's the same thing. Y'all see? So however tall this is how wide this is. I don't need to know how wide it is. I need to know that. So how wide is that? It's y over 2. So it is 8 minus x over 4. It's divided by 2. Okay? If it said it was a square, then r would just be the side of the square. Okay, as soon as we've got this, and then calculator, and it's no problem. So I'm going to take the 1/2 pi out, because I like to. 0 to 8. I'm going to put whatever I determined was the radius, 8 minus x over 4, and I'm going to square it. Does that help a little bit? Okay. If this had been just a square, we'll do this in blue. If they had said cross sections are squares, you would have drawn this picture. Yes? And you would have said no 1/2 pi, and you would have said side squared. Yes? And what would the side be? 8 minus x over 2. Okay? Do I see? Okay, now we're going to practice the calculator part. I do not want to be missing about that at all. Pull your calculators out. I'm going to go to y equals, and I'm going to put in the function that's not square. We're going to type in 8 minus x divided by 4. The place where you run into trouble is where you try to type too many things with parentheses and squares on them, you start getting in trouble. So put something in y1. Okay? Everybody there? Go back to the home screen. Math what? Math 9 from 0 to 8. What do I want to put right there? 1. And what do I want to do to it? I want to square it. You see how you don't have to fool around with all those parentheses when you do it that way? This will be true when we put in y1 and y2. You have r squared minus r squared. You would put a y1 and a y2 and do it like this. Okay? And don't forget your dx. I forget it all the time. You said like a million answers to this question. Hit enter. Okay? Guess what? That answer is probably one of the choices. It's not, right, okay. But what do we got to still do? Multiply by a half pi, yes? Okay, so divided by 2 and times pi. Sometimes they'll actually change that to a fraction and put pi on the end of it. There's the answer. Okay? Everybody good? Okay? All right, so there's our little warm-up on multiple choice. If anybody wants to go get one quick donut, now's the time before we start 2004 problem number. Any bathroom you want. There's a teacher bathroom down here.
I don't know it's one of the. Sections here in 1990.
Here is the section.
Part. What is part B? Part B is one I don't know. She doesn't have. No, I don't.
Send me an email and I'll get you one.
Ms. Farmer, right now my calculator's taking like 2 minutes to load for each.
Whenever it does this, is it doing everything?
Tolerance not met.
I don't have any idea what that means.
No, my
That's a long equation. I don't know.
It's Peter better than that.
I don't know, I've never heard it do that before. Whenever it takes more than, it does take a long time, you put something in one and then you tell it to do things. But if it takes more than 30 seconds, just hit the on button and go check and make sure you didn't type something wrong and do it again. You know how sometimes you turn it off and turn it on again?
Okay.
Okay.
Wait, are we not waiting?
We are now going. All right, ladies, we're now going to 2004 B. I know it seems like we would start with A, but A had a little twist to it, and we're going to do B first. 2004 B. Number 1, this is with the calculator. So we're going to practice how to use our calculator to achieve what we need to achieve on this, okay? They gave us no graph on this. So first, read the problem. Instead, a nice little sketch of what this looks like. If you get a bad sketch, that's definite trouble. Okay, 2004 B, number 1. There's no picture there. And you'll know you're on the right one if you've got this equation. 2004 B, number 1. Okay. Sometimes they give you the picture. That usually means they're going to give you slightly harder questions. Okay, or at least one harder question. Okay. If they don't give you the picture, that usually means the questions aren't as long. You got a calculator. This is on 1 and 2 are on the calculator. In fact, if you decide to practice any of these outside of here, 1, 2, and 3 will with the calculator. They've changed it since then. It's only 2 with the calculator now. But for the ones that you have in your packet, 1, 2, and 3 will with the calculator. And they're still the same kinds of problems they put in the first 2. Okay? Draw a picture. If you don't draw the picture, you can still get full credit for the problem. But if you draw the picture, better visualization of what's going on. Okay, got it? Yes? And what does it say? What's question A?
Find the area.
Find the area. Okay. Okay. Area equals. We just warmed up on area. Okay. Area equals. have your calculator. Integral, from where to where? 1 to 10. What do you suppose some people are gonna accidentally put on the bottom?
0.
Absolutely gonna happen, okay, 1 to 10. And top minus bottom, but the bottom this time is the x-axis, so it's like top minus 0. Yes, these are the first ones we did. So what's the top?
X minus 1 is 0.
Why are you squaring it?
Oh, I mean, for.
Yes, square root, okay. All right, everybody, just the equation, yes? dx. And then you write the answer down. That's it. 3 points. What? 3 points. So write down 18. Next time you do it, some other time you do it, it might come out 17.9999999. Okay. So 3 decimal places. If it's got 4 zeros and some other numbers, then it's probably just the integer. So this answer is 18. 3 points. Okay. B.
And the reason is, you just do the root x minus 1.
Yes, it's technically the top minus the bottom, but the bottom is the x-axis, which is 0. If there were some other pictures here, it would be top minus bottom. Okay, we'll get to one of those in a second. Okay, B. This one says volume. We need to revolve this thing around what? 133. Now, I am a big fan of redrawing it. I think when you get too much on one picture, you start having trouble. That's what I do. So I'm going to go around y equals 3. You might want to note where y equals 3 is. For example, that point right there is 10, comma 3. You may or may not need that 3 for something, but that's what it is. So my y equals 3 is right here. There it is, y equals 3.
They do not give us in the past.
That's correct. However, if you've got it written there, and you're looking to try to decide, do I need to give this girl 1 out of 3 or 2 out of 3? The more good work you have there, the better chances you are for getting 2 out of 3. Okay. So, whole or no whole?
Whole.
Okay. If I rotated about the x-axis, look, if I rotated about the x-axis, there would be no hole. Because an edge of the shape is the rotation axis. Okay? So this is going to have a hole. So write your structure thing. Write your structure. Get your first point. I should have gone ahead and drawn instead of dx, but anytime the axis of rotation is horizontal, it's dx. Yeah? Axis of rotation is horizontal, dx. Axis of rotation is vertical, y. Yeah. 110. Only if you want the right answer. Okay? I didn't do that on purpose. I also have done it almost every single year. Okay? So now we need to identify R. Okay? In words. How do you draw R? In words. From the axis of rotation to the outside edge. Put your pencil on the axis of rotation. Draw it to the outside edge.
That's little r.
That's big R. Big R. What's little r? Axis of rotation to the inside edge. Little r. I know you're not going to have colored pens with you when you do this. Little r. Okay? That's it? I don't remember. Probably. Alright, so now you need to look at each thing and determine what is big R, what is little r. Do I subtract? Is it a constant? Do I add things? How do I get it? R is constant. R is 3. That's big R. Little r is 3 minus y. It's 3 minus y. Very good. What's y? Okay. Now, notice when you're doing this, you guys can kind of be, look, y'all are smart math people, or you would be sitting in this room, okay? And because you're smart, for many years you often didn't write everything down. Yes? Yes, this is true. Or you wrote it in your own way, okay? Nobody wants to look at it in your way. They want to look at it in the way other people do it, at this level, okay? So watch that you're being good and clean with your notation. You call it R over here, call it R over here. Yes? Okay, now we need to get it written down correctly. Pi, the integral from 1 to 10 of 3 squared minus 3 minus the square root of x minus 1 squared. Yes, I don't think they take a point off for that lack of bracket right there. I think they're, at that point, they're kind of going, okay, as long as they get the right answer, but technically it's supposed to be that. We good? Okay. We need to get this in our calculator correctly. We're practicing that today as well. How, what do you think you want to put into Y1? If you want to, you can put 9. But you definitely want to put this. I would put the inside part. In fact, if I were doing this, into Y1, I would put 3. And into Y2, I would put 3 minus the square root of x minus 1. I would put the thing that's being squared. And then in my, on my dy, on my definite integral, I would put the squares. But there's, you could also put the squares in here and then just say y1 minus y2. You know what I'm saying? Okay? So either way you want to do it, you can put the squares in here. I just think too many parentheses in one place is where I start to run into trouble. And I got 67.5 pi, which is the same thing as 212.057. Anybody there? Okay. What do you think is the most likely thing to happen to you? If you've got all of this pi, forget the pi, and write down 67.5. 3 points. You forget the pi, how many points are you going to get? 2 points. Okay.
I
Can't hear you.
do they care what they?
No. Okay? Ready for number 3? Okay. Part C, whatever that is, draw the picture again. Well, what they expect you to do on these is really keep 2 paper per problem. 2 dots. These actually offer 2 pages per problem.
I can answer, but I don't see if there's anything on them.
Okay, well, think that over again, but I'll look while y'all draw the picture. Square root's on your X, it's not on this one. On your paper too, Okay, which way does it say to rotate it this time? Around a vertical line, yes? X equals 10, very good. No hole, because the rotation, the axis of rotation is an edge of the figure. This is like a mound, like a hilltop. It's just that way instead of this way, okay? I don't think it's a bad idea for you to write a note to yourself, no hole. What's your structure?
This has to be kind of a dumb question, but the dotted line is where you're rotating,
Yeah.
so that would be considered the line that says no hole.
Right, correct, huh? All right, and also because it's a vertical line, we are dy. So I'm gonna put pi times the integral from dy is gonna be 0 to, going with that.
But why,
No, you agree, there's 3.
why do you have a pi up there? For this pi r squared?
It's still rotating. I'm still doing a rotational problem. Doesn't it say revolved around or rotated about? Then things are circles. Okay? It's when it says cross sections are perpendicular or semicircles and something else. Okay, so there's your structure, 1 point. You gotta get the pi, you gotta get the 0 to 3, you gotta get the r squared. 1 point. Okay? Alright? We gotta figure out r. Okay, draw your little box. From where to where? To the edge. Now, when the axis of rotation is away from the x or y axis, you need to think about what you need to add or subtract from them, yes? What's this little distance right here? It's x, it changes, yes, and this is what I'm looking for. So what is r?
3 minus 10 minus.
Okay, and what is x? I do not know. I know what y is. Y is the square root of minus 1. So I need to turn this around to what is x? Okay, so therefore, what is r? 10 minus parentheses y squared. See all the places for little mistakes? Yes? So what does r actually end up being? Alright, so write your final symbol. Oops. You have to work hard for that second point, don't you? Okay.
Why is the formula, if the initial formula says pi, but why is it not 1/2 pi, so it's a semicircle?
It's not a semicircle. This is a rotational problem. So the difference between where you rotate this, then when you're looking at a whole circle versus the ones that say cross sections or semi, means they pop out of the board as you in one direction only. You don't get that circular thing, okay? All right, in the calculator, decide what you're going to put in. I would put the inside stuff in. That's just where I try to keep from having too many parentheses in any one place. 9.65 or 107.15. Don't leave off the zeros. It says 3 decimal places, put 3 decimal places. They're not picky about that last number, if you round up or down, they don't care. Okay?
So when we type it into the calculator, should we put the y, or should we just
Put X.
put X?
Yeah, it doesn't care. Doesn't care. Okay? Everybody see? Now, if you were going to work one problem over again before you take the AP exam, I would work this one. Super straightforward. You know? Super straightforward. Almost positively, 2 of the 3 parts to this question are going to be 2 like this. An area, an easier volume, and a harder volume. The other kind is the cross-section kind. Okay, but this one would get you, okay, I can get 6 points for another. Does that make sense, everybody? You're going to work one over and I work this one. It's another straightforward you're going to see. The rest of them have 2 straightforward questions and 1 more that's a little wonky. All right? So I'm going to turn the recording off right now. Save a little recording time. And y'all are all going to go to 2004A, number 2, 2004, number 2. First one, number 2, and work part A and part B only. And I'm going to stop recording for a few minutes. Okay, y'all are finishing those up. I'm going to get some stuff up here for those people who couldn't be here with us, just so that they have this. And all right. As y'all are finishing those up, I'm going to tell you that what I've written up here, so take a look at what I've written, will get you full credit. Look at what I've written up here. This will get you full credit. Okay? This, as long as G of X is defined on your paper, and as long as F of X is defined on your paper. So Rachel just said, oh, I got them backwards. You got to make sure you know which one you put in Y1 and which one you put in Y2. Does that make sense to everybody? That will give you full credit for this. Now, if you change this to Y1 and Y2, and nowhere on your paper have you told them what Y1 is, and you told them what Y2 is, nope. But if you have, then that's okay as well.
So you can say, like, Y2 equals F of X.
And yes, as long as that's on your paper, yes.
So, but since Equifax gave us a design in this problem, we don't just.
You don't have to, so you can just, it's just up to you, okay? All right, now we're gonna take a look at part C. First, everybody just read it. Now, at this point, some of you would say, okay, I'm gonna go work the next problem. Okay? But let me tell you what they're trying to do here. This kind of question, well, what have they done? They said, h of x is kx 1 minus x. Yes? Okay. This thing about throwing a k in is one of their standard wacko questions. Where they throw it in is different. They might throw it in an area problem or a volume problem. They might throw it in a velocity problem. They might throw it in somewhere, but they love to throw that k in. Okay? A constant multiplier, I have said more than one time, is your friend. It is a constant multiplier. What does a constant multiplier do to a graph? It just stretches it. It doesn't change its overall general shape. It just stretches it. So look at h of x and take a look at the two equations they did give you. Look at it. What is it going to look like? What is h of x going to look like? It's going to look like f of x. It's either going to be taller or it's going to be shorter, but it's going to look like f of x. So what's your picture going to look like? The same picture they've given you. Okay? So was it really hard? No. What threw you off? K. Yes? That's what it was. So when you get to 1, take a breath. Just try to remember, constant multipliers are my friends, okay? And see if maybe it's not as bad as you think. All right, so that's the first thing you had to notice. And then what does it actually say to do? Your region. Okay, cross sections perpendicular to the x-axis are what? Squares. The picture still looks like this, right? There's h of x on top, and what's on the bottom? G of x, right? Yes? Okay. Cross sections are squares. What's our formula? That's side squared. I'm just a big fan of the word. You know, if I put an S on there, I feel like I have to label an S somewhere. You know? So it's side squared. Yes. So it's still from 0 to 1. Okay. Cross sections perpendicular are squares. Yes? Okay, we can practice a second one together. So if you go back and look at that worksheet, you have a second full example. Okay? We draw this. There it is. That's the base. And what did I tell you to do to it? Put it down here and draw whatever picture they told you. That is supposed to be a square. Okay? And here's my side. So how long is that side? Top minus bottom. Yes.
When you're doing these ones where it's a cross section, are you always gonna draw the like your little box vertically?
As long as it's cross sections perpendicular to the x-axis.
Oh,
Yes, which is all I've ever seen. If they happen to decide this year for question C to say cross section perpendicular to the y-axis, then you flip it and just keep going. Okay, we're going to do enough of those. Hopefully, we'll do okay. All right. So what's the only thing you really have to write on your paper? 0 to 1 h of x minus g of x squared dx. There you go. Okay, except it's a little different this time. What does it tell you? What's the third little thing we threw in there? Ready? Ready to last point? Set up, but do not solve. Set up, but do not solve. Y'all see? Now, there's a slight chance, having not graded these myself and not been into a workshop where I've seen this problem graded, there's a slight chance that they would give you 1 point less than full credit for leaving the H and the X in there. All right? I mean, the H and the G. But every time I've been to any other problem, they've always said you can do it as long as H and G are defined. Okay, or defined something. Make sense, everybody? Okay, big breath. one more problem, we're just gonna take a look at it briefly. 2005A, number one. I'm not actually gonna work through all of this. 2005A, number one. I'm gonna do three of these possibilities. One, you gotta take one of those next week over this material. So it's like a name review section, yes? Okay, two, it's always on there. Oh, I don't think I've seen one in the last 15 years that didn't have this on there. And if it doesn't have it as a free response question, then there are going to be 3 multiple choice questions, an area one and 2 volume ones. I guarantee it's always going to be there. Okay? So that's why we're doing 3 of these. Got a beautiful picture there for you, yes? I don't know, did it have a live one there, or did I add that? I think I've more or less just reproduced what they've given me, yes? Now, how does this differ from the other one? There's 2 different areas there. Happens every 4 or 5 years. They throw one at you, just have 2 different areas in. Okay, there's R and there's S. Do they see them? I think that's what you have to find, yes? Okay, so we're gonna do this without actually punching any buttons on our calculator. We're gonna write down enough information that we can get part credit even without picking up our calculator, okay? So question A says find area, which one? Area R is the definite interval from 0 to, let's go up here and label this point A comma B. I'm not picking up my calculator, I'm just gonna call it A comma B. That point right there, there are M's, yes? So what am I gonna put here? A. Now, when you actually do this, you need to find that point of intersection, store X into A and store Y into B, so when you need them, you can go get them. Does that make sense? Okay, it's area, do I put pi?
No.
No, just add up top minus bottom, so which one? Okay, minus fx. What else could you put if you wanted to? Y2 minus y1. As long as it's labeled, you can do it. Is everybody good? And what else? Yeah. So this way. Top minus bottom, okay? And I'm gonna tell you the answer so that if you wanted to go home later and try this, you can. Here it is, okay? Straightforward, super easy, okay? Ready for B? All right. B says find the area. Yes. I'm gonna erase this so I can keep my picture up there. So what should you do on the picture? What do we call it? And when you find that point of intersection, store them in C and D, and then you can go get them. Okay, if they're nice numbers, and of this pair, one pair is 2 nice numbers and one pair is 2 yucky numbers. Okay, then you can change it and just put, 1,5 or whatever the point is, if you want. Okay, and then we're going to say from A to C, what has to happen here? That's G. Yeah. Okay. Again, put a note to yourself if you want to say, let me make sure I can get that, but I don't think these are particularly difficult. Oh, yeah, they are, because there's a sign and a 4 to the negative X, so that might be worth your time. Okay? Everybody good on A and D? You got this area thing? All right, now we're going to get volume. Let's see. Which volume are we? Which one are we revolving? Yes. Is that a hole in it? Revolving it around, like equals One. Down in the median will be, what's R? The front one's top of that, is that right? One, two, that. So big R is, f of x minus what? Minus negative one. Now, since that's a negative, minus negative every single time, if you wanna make it plus, you can. Minus negative one squared, and the bottom one is e of x minus negative one squared, and it is dx. What about missing? Bottom to the top. I put them in the first one, but not put them in the second. Okay, everybody see? Any questions? That one should feel pretty straightforward too after the second one. Yes? Okay, and that answer would be 4.5587, and we are going to take a 5-minute break. Okay? 5-minute break, I'm fast for water. Here's some little bottle. Bye, whoever's watching.
The bathing room? The water closet?
Sure.